a beam PQ has a mass of 20 kilograms. So we've got this beam here that weighs has a mass, of 20 kilograms. It's supported at S, 2 meters from the right. So 2 meters from the right, it's supported at S from the right hand side, and then from the left hand side, 1 meter in, it's supported by a rope which has a tension T. If the beam is horizontal, i.e. in equilibrium, find the reaction R and the tension in the rope. Now, there are two things that you need to remember. The system of parallel forces will be in equilibrium if the first thing, the resultant of the forces is 0 and the total moment of the forces about any point is also equal to 0. So for a system to be in equilibrium, it requires two conditions. If we resolve in the direction of forces, the resultant will be 0, and secondly, and both have to be, if you take moment about any point, the total moment is 0. So the moment of forces is 0. Okay. Let's just add in here the moment of forces is 0. Okay, solving vertically, and we're going to take upwards as positive and downwards as negative. We're going to have R plus T in the upwards direction, minus 20 newtons, okay, will be equal to 0. Taking moments about S, so we won't need to worry about the resultant here, so we're going to get a value for T straight away, I think. Anti-clockwise is positive, so the anti-clockwise is going to be this one, is going to drive it around. Anti-clockwise is going to be 20G times 2, it's 2 away from S, and the clockwise will be negative, will be this one here, so that's going to be minus T times 5. The total moments about S are going to be 40G minus 5T is equal to 0. We're going to call this equation 1 and this equation 2. Writing them out again, and we'll solve them simultaneously. We can get the value of T straight away from here. So we're going to have from 2, 5T is equal to 40G. T will be equal to 8G, and G is 9.8 meters per second squared. That gives me 78.4 newtons. Substitute into equation 1, so we're going to have R, and I'm going to put 8G minus 20G is equal to 0. R minus 14G is equal to 0, 8 minus 20. Therefore R is 14G, and therefore that gives me 137.2 newtons, taking G to be 9.8 meters per second squared.